So this is going to be an extremely random video. So today, Einstar Shining 3D, they released a new update for Xstar Hub software, and I gave it a shot. And on the Einstar2, I gave laser mode a shot, and in all honesty, really impressed. So this is my scan of the whole car in laser mode. So as you can see, it's really nice, and it more or less aligned from side to side, which is really impressive. Now, as good as this is, it's really important the fact that the data is accurate, because if it's not accurate, it could be the most flawless looking thing ever and useless. So what I want to do is a random test. I want to make a Canard. Now I won't be using it on my car just because I'm doing the wide body thing, but I figured what better way to test the data than have something that should match up right to the OEM placement, if you will. So what I'm going to do is just create a random generic shape that's going to overlap a lot of elements of the factory lines, because I want to more or less double-sided tape directly to the body and see what happens. So let's give it a little bend, just kind of like that. And then maybe we'll add a little bit of surface like that. Give it a little bit of an angle, so that way when we smooth it out, so something like that. Nothing too crazy, but just enough to kind of force it to interact with the body. Now, here we go. What I'm going to do here too is kind of add a little lip. I have something like this on the GTR, so it'll look cool. Okay. And it's really dense. I think it's like 72 million polys, so the data is very heavy. So we'll just do something like this. So when we turbo smooth it, it holds true. So now what I'm going to do is turbo smooth it by, let's say, 3. Okay? And it'll make sense in a second as to why I'm doing it this way. So now I'm going to do another edit poly. Go in and remove all these segments, and then these right here, I'm just going to connect like that. Perfect. All right. So now what I'm going to do is go into just the side view, and I'm going to make myself a little reference plane, so a little stencil of what I need to retopo, if you will. So this is my working area of what I need to recreate. And because I do not want to utilize the CAD data per se, so it'll make sense in a second. So what I'm going to do is create a plane like I normally would. All right, make sure it's 0, 0. We're going to model on the surface like I always do when I retopo. I'm going to offset it by 0.1. I don't want a lot, just a little bit. And now what I'm going to do is go in and remodel just this area. This is the area that I know I need the Canard to sit flush up against. And now I probably should have detached the working area just so it's not so laggy. So that's what I'm going to do. I'm going to pause this real quick and do it. Okay, that took forever just because of how dense it is. So I'm changing it to this. And now, just like I always do, just go and start modeling on top. Nothing too crazy, because this is going to be my cutting plane. So it all makes sense in a second. There we go. What I'm going to do is just adjust these edges to go over here. Looks like it froze up. But there we go. All right. All right, so what I'll do is ring this, connect it by like 3, maybe 4, just so I have an even poly flow. I'm going to conform. I think it's going to be the y-axis. So 1000. Nope, that ain't it. Maybe. Oh, it's X. There we go. Nope, wrong. So it's Z. There we go. Now we're just snapping it to the surface, just like that. There we go. Easy enough. Let's take a look at what that looks like with smoothing. So as you can see, we're very tight. I might bump it up to it's from 0.1 to 0.2. So let's just go to conform. And we'll just fix all these real quick. There we go. All right. So there's that. No turbo smooth test. That. Oh, we have the hard line. Well, it did it. I guess I'll just add another cut here and here, because this will make it, even though typically I'd use smoothing groups to fix that, but that should do the trick. There we go. Okay. Now I do want it to go over this plastic trim as well, so we'll just extend those out. Extend those out. So there it is. Really want to do smoothing groups on this, but maybe that's not the smartest thing. Okay. I'll just connect it twice. Or split loop. Go. That's good. Let's conform these segments. That, perfect. Extend this one more time. That should more or less finalize my cutting reference marker. That, and then we'll connect it because it does need a sharp edge right there. And again, this has absolutely nothing to do with my wide body kit. This is simply to test the accuracy of the laser scan mode. And see how it got all mushy? It just needs another segment of edges right over here. And that should, in theory, preserve its shape. Yep, there we go. Maybe I'll just add one over here because I do want to recreate the scan data the best I can. Okay. I need to offset these edges, so maybe I'll remove that just for the sake of ease. Here we go. Alright, let's conform this real quick. Take a look, that should be better. Not close enough. So I'm gonna offset it by about half a millimeter. Okay. So now we're gonna take those out over there. And then finalize it by taking them out over here. Like that. There we go. And this will all make sense in a second as to why I'm doing this. So now I'm gonna do some swift lips and now conform all these edges. Guess we have to do something like this. Go. Okay. Now let's see. Let's see what we got going on. Looks like we need one more set of edges right there to really help it take shape. Here we go. Okay. So now what I'm going to do is add a shell modifier. And let's do, that's 1 millimeter. That's actually pretty good. So let's do 1mm offset. So this in theory is going to glue right onto it. So then, since I am 3D printing, I could be lazy. Let's do this. So now that we have a 1mm offset, I am going to delete this. And this is like extremely lazy modeling right here. That. So now I'm going to shell this by like 8mm, right? So this is my Canard. Now I want the mounting tail, if you will. So what I'm going to do, this is 100% not the way to model, but I could get away with it on this situation. Where the heck is it? Okay. Perfect. So this will all make sense. This is extremely sloppy, but I think it's going to work just fine for my needs. So I'm going to edge constraint that, edge constraint that. So as you can see, and actually to make it flow better with the body lines, even though it's so stupid for me to even care, but whatever. Edge constraint. So now, let's do this. So we have our Canard, and I'm going to add a shell. So we want some thickness to it. So we're going to do 4mm. I don't want it razor sharp. We'll make it look good, whatever. Now let's do 8. Let's make it really nice and thick. All right. Then before I do that, actually, what I'll do is add an edge loop here, so that way the corners look pretty accurate all around, like so. All right. So now we're gonna trim the fat. So we're gonna do an edit poly. I'm gonna do bi-angle, and this should select all the backside faces. Granted, I could have done this all within the shell modifier, but whatever. There we go. Now what we're gonna do is tie boolean. Love this state. And we're taking away that face. See that? So there we go. So now that I have that done, here is my little mounting bracket, if you will. So I'm going to convert this, or I'm going to just add an edit poly to this. What am I doing? It's just shell. I don't need an edit poly. I need a shell. It all makes sense in a second. Okay. I don't like the direction it's going in. So yeah, we're going to do it manually. So I could just do this. View align. Make it nice and flat. Flip it. We're just going to extend this out. Flip these. And it did not do it right. So what I'm going to do is poly to poly. And now it should bridge it just fine. There we go. All right. What the heck? Something's bizarre. There we go. Okay. And now this was the one that I mentioned. I extended it by 5. So you know what? I think the best thing I can do is, instead of doing that, I'm going to duplicate this one, delete tie boolean, convert to edit poly. Now what I'm going to do is select, let's say, these edges, delete them. Delete this, delete this. Now I should have this one segment. Perfect. I'm going to go in, delete that. Now I have this one segment right here. The reason why I'm doing this is I want my mounting thing to kind of flare off in a very elegant way from the original Canard. So that's why I did what I just did. So we'll give it, whoops. That, let's see if this, nope, see, for whatever reason, this bridge isn't working nicely. Even though it's such a basic thing, it should work perfect. All right, now we're on to something, I think. Okay, so the only thing left is, as you can see again, this angle nonsense. So what I'm going to do is turn on edge constraints and just quickly manually move these segments over. These I need to really shift over here. And I really don't need to try this hard. This is just a test, but you want to, I don't know why I'm even trying this hard. Okay, now we're gonna do tie boolean. We're gonna select this one and change it from subtract to intersect. So see that? And now in theory, there we go. So that's why I did what I did. So now we have our mounting flowing perfectly with the body. And because it's a non-destructive workflow using tie boolean, so instead of 8, I could do like 3 or 2, and see how it's interactive? It's really neat. So there we go. So this, in theory, and I'm gonna 3D print it, and we're gonna test it on the car. If the laser scan mode is as good as I hope it is, this should fit right onto that car and fit like a glove. And it's a very minimal offset. It's 1 millimeter, so it's enough for me to throw some double-sided tape on here and check it out. So I'm gonna go into a projects folder where Subaru WRX, and you can't see this on the monitor. Test. We're gonna export this out. Hopefully I could 3D print it in one piece. I really don't want to deal with overthinking the slicing. So Canard, STL. All right. Let's open up Bamboo Slicer and see what the heck we get. This will be really neat. If this works, if this scan quality is good and accurate, I'm excited because laser mode was so nice to scan with. Yeah, it's precision. We need to make sure it works. All right, let's see how big this thing is. All right, let me see if I could just rotate it. Worst case, nah, I can't. So what I'll do, something like this, so we have as little overhang as possible. And then we'll cut it right down the middle. There we go. And now there we go. We got 2 of these. Because of the nice L shape, they should stay pretty planted. Let's see how well it slices. Beautiful. That's the great thing about 3D printing, is you don't need it to all be one object like you would with modeling for proper resolution stuff. So let's see, 4 hours. That is extremely long. But it is what it is. I'll just set it and I'll make a video tomorrow of me testing it on the car. 3 hours with that. It's a really big. And honestly, I have various printers, so I could knock it out tonight. But I really just don't care. So, okay. I'm going to throw this on the printer. Print it in PETG because it's already inside the printer from earlier today. And then we will see how this works. I'm actually going to add a brim to be safe. Outer brim. I'm just going to do 10 to be safe as well. Okay. So this is it. this is my game plan. I'm gonna 3D print this one, and I honestly like it always facing me so I could take a look at it. This is just a stupid personal preference, really irrelevant to the video. But I'm gonna throw this on the printer, print it out, and then we'll record with the proper camera in the garage and see how well this fits. Because if it does what I hope it does, this is gonna be so exciting for me, because this is gonna be my new master data set. As you can see, like, I got the whole car. We got the rear bumper, the trunk. I want to design a duck bill possibly, and now I could start working on the wide body, rear over fender things, and then yeah, this will be my new foundation for the WRX CAD model. So yep, gotta print this and we'll have an update.
Okay, got these printed last night, and I threw some super glue on them. Dropped them, they cracked. So I'm heating up my little wood burning tool, and I'm just gonna quickly just connect the back side and then test fit them on the car. Because again, this is just a quick test to see the accuracy of the laser scan data and how well it mounts up to the vehicle and the OEM body panels. So we'll take a quick look here in a second. And so this surface right here is the joining surface. So I wanted to add as little imperfection to that as possible. So I am actually going to do all the plastic welding on the underbelly, if you will, and the back side. So I'm just too lazy to really find a perfect way to hold it. So let's just see. So let me adjust the camera so you kind of get an idea of how I'm approaching it. And it's really stinky stuff because of the super glue. But I do enough to... Oh man, this stuff's awful. To help it hold the shape, which kind of does. And the trick is as minimal of a seam as possible, because that would mean it's offsetting. And every little offset when you try to do what I'm doing with this test, and that's get it to fit as perfect and flush to the panel as possible, all the offsets do create issues. So just holding it as snug and tight as possible. And that super glue is really bad. All right, and then what I'll do here too is there's no super glue here, so it's gonna be very easy. Again, I'm not making a pretty part. I'm just testing fitment with a blue laser scanner. That's it. So I'm just gonna get that plastic going and then just hold it as snug as possible to make sure the seam is more or less non-existent. Here we go. So it ain't pretty, but it's holding, and that'll work. And just for the peace of mind, what I'll do now is really go in on a heavier burn, like really melt some plastic now that it's holding true to its shape. That way I don't have to worry about it coming apart while test fitting. Now I'm putting this way away from my face. That super glue is disgusting. That's why I don't like using super glue, because when you start melting plastic and you heat up that super glue, it's really bad. Not just the smell, but the way it interacts with your eyes. So there we go. See, this was my hero. This is the game plan right here. So you see, this line is perfect. This line's perfect. The seam is almost not even present. And that is, to me, a really good print. Now we're gonna test fit on the car and see what the heck we got. All right, so here we go. Now, I don't know exactly where it goes, so we're just gonna kind of finesse it. But in theory, it's kind of like that. Right about there. So, as you can see, we are actually pretty darn flush all the way around. That area is okay because of how turbo smoothing worked, so that little crevice. But the hero surfaces that are touching aren't touching perfectly. So I'm gonna grab some double-sided tape, throw it on the back side of this, and do a gentle mount and just kind of show some teaser angles, if you will. There we have it. That 3D print actually fits really nice and really lines up well with the curvature of the OEM panels. We got the little offset because of the double-sided tape thickness. And if these were real, like on my GTR, these would be riveted into the bumper anyway, so they wouldn't just be on double-sided tape. Not very smart, but I don't think that's the smartest way to mount Canards with the downforce and all, unless you want them to go flying on the interstate. But anyhow, proof of concept worked. So what I'm gonna do is I'm gonna record a video, but it's gonna be me laser scanning the actual side skirt, because I laser scanned the whole car with no video just because I didn't know what to expect. Now that I know it works and I'm a lot more comfortable using the laser, I'm gonna actually scan the side skirt and do a project breakdown of that. And then what I'll probably do on the design side is model this. I'm sorry to include it in this video, it's probably overkill, but I'm gonna model these brackets and 3D print all of them so I could make sure the 3D scan is accurate and that my 3D scan with the clips mounts up to the OEM panels. And if it does, then I know I'm good to design. So that's the game plan for that. I'll probably do this recap in that video too. But anyhow, the Canard is great, useless, but it's good proof of concept that the laser scan data is accurate. And that is amazing news, because now we have a full vehicle scan, blue laser mode. We just got to test the side skirt next. That's going to be a really big, long part. If it works as good as I hope it does, off to the design stages fully, because even though I've been designing already, I've still been skeptical on how accurate it is when it comes to the whole assembly. This gives me a lot more confidence.